Network address translation, also known as NAT, is one of those concepts that I don't care how many times you learn it and you set it up and you configure it, just every time it's just so cool. It's just one of those things that it just gives you a buzz every time you set it up. So what we're going to talk about in this video is that NAT. We're going to understand what NAT is all about, the need for NAT. You may have heard of it before. We'll look at the forms of NAT, and then finally, we're going to configure NAT in this series using the SDM. In order to understand the need for NAT, you need to understand a little bit about the internet. The internet is usually represented by this cloud where everybody's just like, oh, you're connecting to the cloud. But if you were to pull that cloud cover back, what you would see is just this network of networks and networks and networks and networks. Hundreds and hundreds of thousands of networks that are all connected together by routers and different internet service providers. And you look at, say this over here represents your home or your business, and you have some router that connects you to your ISP. Well, that ISP is connected to other ISPs, and they connect to other homes and other businesses all around the world, and everybody just ties into this one massive network of networks. Now, this network grew and grew so large that we eventually ran out of public IP addresses, meaning IP addresses that would work from the IP version 4 address space, which, as you know, looks like this, where every number goes to 255. If we were to pull back the cover of the internet and connect everybody directly to the internet with using internet valid addresses, there just wouldn't be enough of these addresses to go around. We would exhaust the whole thing. So, NAT, what its major goal is to allow multiple devices to share an internet IP address. Now, NAT does many other things, but that is the reason NAT became famous. And it's kind of ironic. NAT was the great savior of the internet in the, well, I guess it would have been around the early to mid 90s when it first was introduced. And everybody's like, oh, this NAT is so amazing. We thought the internet wasn't going to make it, or we were running out of IP addresses, and that NAT sustained us. And everybody loved NAT. Nowadays, NAT has become a prohibitor of progress, meaning there's this other protocol, perhaps you've heard of it, IP version 6, that has been out there for a decade, but nobody wants to use it. Because we've got NAT to keep us going on life support, so it seems, for quite some time. In IP version 6, well, there's just no business need to move everybody to it because NAT allows everybody to share a single address. Well, there are some disadvantages of that, and I'll show you that as we go along. Now let's get a perspective on how NAT works. And when you see this, I think you're going to be thinking, genius. This is just a brilliant idea to make this thing happen. But to understand NAT truly, you need to understand TCP source ports and destination ports and that kind of thing. So here's the idea. We've got multiple computers inside of our networks. 192.168.1.50, 51, maybe there's 52, maybe there's 100 different computers inside of our network that are all wanting to access the internet. But we only have one valid internet address over here, 200.1.1.1. Now, the way that NAT works is when this computer goes to the router to access the internet, the router realizes, you have a private address, and private addresses are not routable by the internet. So what I will do is I will translate you to use this 200.1.1.1. So let's say 1.50 decides to access cisco.com. Well, when it goes through the router, it will become this public address. Now, if that was all there was to it, the problem would be that once one person went through, they would become this public address, and then nobody else inside the network could use that address. So what the router does with NAT is combine the source port number to make these translations unique. Now remember, whenever we open our web browser or any network application and access something using TCP/IP, it has a source and destination port number. We'll say when 1.50 goes to cisco.com, it's using a web browser. So it's going to use destination port TCP 80 using the TCP protocol. That's the well-known port number for HTTP access. That's web browsing. But when you open that web browser and establish that network connection, the web browser, or I should say Windows below the web browser, generates a unique source port number. We'll say in this case, it just made up 6751. So 6751 as the source port number and sent that to Cisco. Now when Cisco gets that, it's going to respond and send it back to a destination port of 6751. And when your PC gets it, it goes, oh great, you're going to go to that web browser window, and it pulls cisco.com graphics up in that window. So what NAT does is use that source port information to make the translation unique. So when it goes into this router on 6751, it will come out as 200.1.1.1 colon or source port 6751. And inside of the router, this table, this is known as the NAT table, exists. So when Cisco.com sends back, the router gets it and goes, oh, 6751? Right. You're going to 192.168.1.50. So when 51 comes through and says, oh, hey, I have a source port of 1536, router gets it and sends it out as 200.111.1536. So theoretically, if both of these computers access cisco.com at exactly the same time, it will send two requests from 200.1.1.1, but cisco.com has no problems with that at all because one of them comes from a source port of 6751, and it'll respond to that individually, and the other has a source port of 1536, so it responds to that individually. So no problems at all. Now you might be thinking, well, wait a sec, how many port numbers are there? Well, there's 0 to 65,535. So 65,536 ports total. So reading your mind, I'm trying to do that right now. I'm thinking you're thinking that what are the chances? I mean, as the clients grow, you may get hundreds or even thousands of clients behind here. Is there a chance that two of them can choose the same source port number? And then how does the router handle that? That's a good question. Well, let's say that, 51 and 50 both chose, instead of this guy choosing 1536, he chose 6751 as well. A 1 in 65,000 chance that he chooses that, but voila, he chose it. When that reaches the router, whoever gets there first, there will be some kind of millisecond difference, will get the 6751 going out on the public. The next person will get, it'll say, well, it looks like 6751's tied up, so let's use 6752 for you. And you'll go out as 6752. No worries, right? Because the web server gets that, sends it back, and the router sees it and goes, oh, okay, well, 6752 has to come back to 6751 on the inside of the network. That's why I put a little asterisk. This form of NAT is commonly called PAT. PAT stands for Port Address Translation, and now you know why it got that name. It's actually translating ports. It's using ports to make each one of these unique. And this system allows hundreds, if not thousands, of internal computers to share that public IP address using a 100 or 1,000 to 1 ratio. Now we're really conserving internet valid addresses. In addition to using PAT, NAT also works with static entries. Meaning, let's say that we had a server inside of our network. It's the 192.168.51. So this PC is actually a server. Maybe it's a web server that has our corporate website. Maybe it's an email server. It could be any one of those things providing services to the inside of our network. Well, that server needs to be accessed from the internet, meaning if it's an email server, when somebody sends you a email in from the internet, it will come in to your router into your email server, and that's how it actually ends up in your inbox. So how do you set this up in a way that allows it to go the opposite direction? Well, that's using static NAT. Static NAT has no problem at all being combined with PAT, or it's technically called NAT overload, which allows all your clients to share that. So you can see 1.50 is still going out on that port number 6751. It's still being overloaded for all the other hundreds of clients that are inside of your network. But we've also added a static entry saying, oh, the address 200.1.1.2, we got that from our service provider. 200.112. Whenever somebody sends a request to that address, I want the router to grab it and send it inside to our web server or our email server. Now, the internet service provider will give you those addresses if you pay them money, sometimes $5 a month or sometimes $20 a month, depending on what service provider you have and what kind of addresses you get. Static NAT maps one-to-one translations, so one IP address can be led into the network for internal access. All right, let's get into the configuration of that using the Cisco SDM. At this level, at the ccent level, Cisco expects that you will be able to use the graphic interface to configure NAT. In part 2, which is what prepares you for your ccna, that's where they want you to know how to do it from the command line. But I'd like, as we do this in the GUI, I'd like to take you to the command line and show you exactly what happens so that you can diagnose and troubleshoot a lot of NAT connections as well. So we've got configuring NAT using SDM. Okay, we are going to be at this computer down here. This is us. Oh, with a little target on us with a happy face. This computer, as of right now, is using this router as its default gateway to the internet. Now, as of right now, let me take you over to that computer. It's a nice black screen. I'll kind of drag you down to the corner where I've got my taskbar. That computer, if I were to open up a command prompt here and just do a IP config, I'll see that I am the 192.168.1.20 address as our our topology was showing, and I should be able to ping my default gateway. Ping 192.168.1.1. Enter. And I do that, and I can see replies coming back, so I'm able to reach my default gateway. Now let me ping beyond that. Let me ping, well, let me bring my, see if I can get my diagram back in the window here. Oh man, I'm just bouncing all over the place. Forgive the sliding windows here. All right, there we go. Got the diagram. So I am able to ping my default gateway router 1. Now let me see if I can ping, well, let's ping the public address, 68.110.171.98. Kind of jump back and forth. Ping 68.110.171.98, which is the other side of the router. And hey, that's coming back just great because the router has no problem with me pinging him. The router is, saying, oh, you're just hitting the public interface on the other side. Now let's ping the ISP. 171.97 is his address. Just hit the up arrow. Do 97 in there. And I am dying. I am not getting through. And the reason why is I'm coming through as a private address. Sorry, I guess I should show. It's timing out. I'm coming through as a private address. So when it gets the ISP, it's saying, whoa, that's a private address. I deny those. I block those. Those are not allowed on the internet. So that's why I have to use NAT to turn on and translate my private addresses into the public to allow them to go through. So let me bring over the SDM. I've already logged into the SDM for our router. This is our router that you can see the IP address right here, 192.168.1.1. It's the internet-facing router. And to configure NAT, I'm going to click on this Configure tab, and you can see these tasks usually comes up on the interfaces, and right down here is NAT. You select the NAT, and you get the choice of do you want to configure basic NAT or advanced NAT. Basic NAT is just PAT. That's the NAT overload that allows multiple internal hosts to access the internet. Advanced NAT allows you to create some static mappings to allow people back into your network, like if you have web servers and things like that. Now, if you've already configured NAT, like say you did the basic NAT, you could always convert it to an advanced NAT scenario by hitting this Edit NAT Configuration tab. That's where you can go in and set in all your static mappings if you want to do that. But for now, we'll just configure basic NAT. Brings up a wizard. It says we're going to configure this, hit next. Now the first thing it wants to know is what interface connects us to the internet or our ISP. Now look at the interfaces. You can see it gives me an idea of what my interfaces are. It tells me what networks they're connected to. Fast Ethernet 4 is connected to the internet, and that's its IP address. VLAN 1 is the one connected to my internal network. That's that virtual interface that all my clients can hit. So I'll say Fast Ethernet 4 is my internet-facing interface. And we have, it says the following ranges are networks directly connected. Check the box next to each one that you want to share that internet connection. So I'll check my private network right here. That'll be the internal one. I choose next. Ta-da! That's it. That's all the basic NAT configuration does. It says click finish to deliver this to the router. You know what? I'm going to cancel that because I want to go to the preferences. Okay, good. I just wanted to make sure that it's going to preview the commands before delivering to the router because I want to show you the command. I mean, oh, do you see that? It's like click, click, voila, NAT is done. I got to show you the commands that go with this. I'm going to choose Fast Ethernet 4, internal network, next, and finish. Now look at what it's doing. This is the commands that it's delivering to my router. This is the command line interface. Now, the first thing it's doing, and this is going to be deep, so follow with me here, is it's creating an access list. Now, this access list is allowing, you can see permitting, addresses that start with 192.168.1. anything. And I'm not going to get into this. This is known as a wildcard mask. It's exactly the opposite of the subnet mask. But essentially, this line is permitting anything that's starting with 192.168.1. Well, permitting them to do what? And we'll find that out in just a second. It also labels interface VLAN 1 as the NAT inside interface, connecting to the inside of my network. The internet interface, Fast Ethernet 4, is labeled as IPNAT outside. Now here's the key command down at the bottom here. It shows IPNAT inside sourceless 1 interface Fast Ethernet 4 overload. Let me read that to you in English. I would like to NAT from the inside of my network, which I've designated the source addresses, the source IP addresses, in access list number 1. What is access list 1? This guy. So I've told the router the inside of my network is represented by access list 1, which says anything starting with 192.168.1. Now, I want to NAT those addresses to the interface Fast Ethernet 4 and go ahead and overload that interface when you do that. That is what enables PAT, which means all those internal hosts can share that one IP address. If I would forget that overload keyword, it would only allow one PC through. And as soon as that one PC got through, our NAT pool would be over with. So it also says, would you like to save? This can take several minutes. That's fine. Deliver it. So I'm delivering that to the router right now. It's showing copy the 9 commands, deliver to router. It is now saving my config. We are good. So with that, I'm going to click on OK and jump back to my client. Now, we saw just a moment ago, same command prompts, nothing has moved. We saw that I was able to ping my router. I was able to ping the public interface of my router, but as soon as I was trying to ping the ISP, I'm dying. So I'm going to hit the up arrow and try it again. Check that out. I am now able to ping my ISP because I'm using the public IP address of my interface. It's coming out. This computer is no longer this computer to the internet. It's going through the router and looking like 98, 192.168.171.98. The NAT translations are happening. Now, there's only one more test we can do, and that is to open my web browser here and shrink it down to micro size. It's difficult. All right, there's my micro-sized web browser. All right, there we go. And you can see, first off, Firefox Start came up because it has an internet connection. Let's just do a couple more tests because I want to show you something. I'm going to type in cbtnuggets.com. Let's see if, voila, CBT Nuggets comes up. We can win an Apple iPhone. Hey, I want one of those. So we've got cbtnuggets.com. Let's just, let me just do nuggetlab.com. Get a couple, I want to get a couple websites up there. Oh, don't look at that. How about www.cisco.com? There we go. So we've got Cisco that's up. Maybe this Nugget Lab is down at the moment, but we've got the Cisco website that's up. We've got a couple websites that I've accessed. Now, what I'd like to do is I might as well do it from this command line. I'm going to telnet over to my router. I'm going to telnet to 192.168.1.1. Oh, of course, this PC does not have Windows Telnet client because Microsoft took out the Telnet client in Vista. Yes, you can add it back in, but it's a hassle. So I'm going to go from my other PC, 192.168.1.1. What? Oh, everything's going wrong. World is falling down around me. I can't spell Telnet anymore. There we go. I'm into the router. I'm going to type in show IPNAT translations. Check this out. I have this internal host right here, 192.168.1.20. That is represented as the inside local address, meaning that's the internal address. Now, as of right now, that is being translated to the public address 68.110.171.98. That is the inside global address. Essentially, that is my internet address. So that is the public address that I'm going to. Now, this outside global and outside local are essentially the same thing. These are all the addresses that I'm accessing. Now, look at this, 64.33. Well, hang on. Let me do this. I'm going to type in ping cbtnuggets.com. And I can see CBT Nuggets is 128 something. I'm also going to ping cisco.com. They are 198 something. You see those IP addresses? Let's hop back over here. Look at that. 128 something. That's CBT Nuggets address. Now, I know it's kind of going off the screen a little bit, but over to the right, I can see it's going to :80, meaning I'm using web services. 128.242.116.211 or 211, that's CBT Nuggets, 80. 2 sessions using 80. Cisco.com was 198.33.219.25. Look at all this action. All of that is cisco.com, all these different web sessions, because Cisco's web page is actually made up of many different web servers that do that. So my web browser creates a separate session each one. So here's my internal host. See this? These are all the unique source port numbers. It just happens to be using 62,370, 71, 72, 73. And as it goes out on the public address, you see TCP protocol, but as it goes out on the public address, it's using that same source port number to make all of these translations unique. Now, I don't have another computer attached to that network right now, but if I did, I would see other 192.168.20 addresses that are going through, that are being added to this NAT table. Now you can see this 4.2.2.2:53 UDP protocol. It's kind of over to the left there. UDP, that is actually the DNS lookup. When I went to CBT Nuggets and Cisco.com, it had to look up and translate their IP address to, or their name to an IP address. That's all shown right there in the NAT translation table. Isn't that cool? Now, as time passes, you can see my NAT translation table is getting smaller and smaller because these sessions are closing. They're timing out. It's no longer active. So they're closing down sessions one by one. But that is how NAT can operate. So now if I do that show run, if I bring my window up a little more, I can see, where can I see that? Right in here, there's my fast Ethernet 04. SDM added this description to it. It says that must be your internet WAN port, and I've labeled that as IPNAT outside. I see VLAN 1, that's my inside address, and it labeled it as IPNAT inside. And then scroll down a little bit more, and a little more. There's my access list that is matching the addresses on the inside of my network. There's the command that's making that happen. All of that is visible to me right there in the configuration. So that is configuring NAT using the SDM. Oh man, I don't know if you could feel it, but I am just aching to show you so much more that NAT can do and the possibilities with NAT. But if I did that, then there'd be no reason to have a part 2 of this course because that would all be in part 1. That's part of the CCNA. That is what you need to know for the CCENT exam. A system to provide internet access to clients that are inside of your company using NAT overload. So what we saw as we walked through this was, first off, the need for NAT. If we didn't have NAT, we would run out of public IP addresses in the snap of a finger. Second thing we saw was the forms of NAT. You saw NAT overload, that's its technical name, aka PAT, and you also saw static NAT, which is the ability to provide internal servers or to provide outside users access to your internal servers. Last but not least, we configured NAT overload or PAT using the SDM, and I got a little bit into the command line as well to show you how you can verify that connection. I hope this has been informative for you, and I'd like to thank you for viewing.